So in this I am trying to explain what is angular momentum and then how it is calculated. Look at this figure. There is a vein, then inlet tip at this point, outlet tip at this point. The corresponding distances are r1 and r2. Omega is the angular velocity. Because of that, the tangential velocity u1 will become r1 omega and tangential velocity u2 becomes r2 omega. Omega is constant angular velocity. Now for series of vanes, that is not one vane, there will be number of vanes which are attached to the wheel, mass rate of flow becomes rho a v1. Then momentum at inlet, mass is rho a v1, the velocity in the direction of u1 is vw1. We know that velocity of whirl is nothing but a component of velocity of v1 in the direction of motion of u. So mass multiplied by velocity gives you momentum. So momentum at inlet is rho a v1 into vw1. Now what is angular momentum? As you have seen earlier, it is moment of momentum. So moment of this particular rho a v1 vw1, which is going that way, is multiplied with r1. So rho a v1 vw1 multiplied by r1. This gives you angular momentum at inlet. On the same line, similarly, one can calculate angular momentum at outlet, which will be rho a v1 vw2 into r2. Okay, further, the same angular momentum at inlet and outlet are restated here. Now, rate of change of angular momentum, which is nothing but torque as defined earlier, right? T is equal to the change, in the sense rho a v1 vw1 r1 plus or minus rho a v1 vw2 r2. Because of that, the expression becomes like this. This plus or minus is again because of the angle beta, whether it is less than 90 degrees or more than 90 degrees. So this is rate of change of angular momentum, which is torque. Now if we want to work out work done per unit time, then again as discussed, it is torque into omega. So expression for the torque is this multiplied by omega. Now what is done here is this omega, if you take it inside, it becomes r1 omega, and you know that r1 omega is nothing but u1 and r2 omega becomes u2. So final expression for work done per unit time, that is output, is now rho a v1 vw1 u1 plus or minus vw2 u2. Input is half m v1 squared or half rho a v1 cube. Now efficiency is output divided by input. If you simplify the expression becomes 2 into bracket vw1 u1 plus or minus vw2 u2 divided by v1 squared into 100. What you should appreciate is if u1 becomes u2 becomes u, this comes out, and 2u into bracket vw1 plus or minus vw2 divided by v1 squared would have been the expression of efficiency in tangential flow. Here it is a radial flow. Because of that, u1 and u2 are not same because of different radial distances. The expression becomes like this. Okay, thank you.